Hello, hi everyone. Welcome to the Stone the Brand. This is our Siva sir. Today we are going to discuss about CBSE Grade 10 Physics, that too electric current. Okay, let's start. So now we are discussing about electric current. The rate of flow of charge is called electric current. The rate of flow of charge is called electric current. I equal to Q by T. The rate of flow of charge is called electric current. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. Okay. The rate of flow of charge is called electric current. I equal to Q by T. So SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So here you can see electric current. Electric current. Electric current. So electric current. The flow of charge is called electric current. I equal to Q by T. I equal to Q by T. Okay. So we can say I equal to Q by T. So SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of charge is coulomb. SI unit of time is second. SI unit of time is second. So we can say the flow of charge, the rate of flow of charge, the rate of flow of charge is called electric current. The rate of flow of charge is called electric current. I equal to Q by T. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area. Okay, I equal to Q by T. I equal to Q by T. So here you can see 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area. Okay, so charge is moving, right? So charge is moving inside of the conductor. So will you say only 1 electron flows, current is flowing? Will you say only 2 electrons flows, current is flowing? Will you say only 3 electrons flows, current is flowing? So we can't say like that. Okay, there are number of charges are moving in the conductor. Number of charges, positive charges are there, negative charges are there, both are moving in the conductor. So then only, in that time only, at that time only, so we can say current is flowing. Okay, so only 1 electron flows, we can't say current is flowing. Only 2 electrons flows, we can't say current is flowing. Only 3 electrons flows also, we can't say current is flowing. So many charges are moving in the conductor. There are many charges are moving in the conductor. So then only we can say current is flowing. Then only we can say current is flowing. I equal to Q by T. SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb and SI unit of time is second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. Okay, so that is electric current. That is electric current. So now quantization of charge. Quantization of charge is nothing but number of charges. Number of charges are moving in the conductor. Number of charges. Okay. So this is the conductor. So I'm taking this the conductor. So positive charge, negative charge, negative, positive, negative, positive, negative, positive, negative, positive. So here number of charges are moving, so that's why we can say plus or minus Ne. Plus or minus Ne. So charges are moving. Okay. So charges are moving in the form of integral multiple. Charges are moving in the form of integral multiple. That is called quantization of charge. That is called quantization of charge. Q equal to plus or minus Ne. Q equal to plus or minus Ne. So N equal to number of charges are moving in the conductor. N equal to number of charges are moving in the conductor. On one electron, how much charge is present? On one electron, how much charge is present? We can see. On one electron, 1.6 into 10 power minus 19 coulomb. Okay, in 1 coulomb, 1 by 1.6 into 10 power minus 19. Okay, so if you do it, see 1.6 into 10 power 19. So 1 by 1.6. 1 by 1.6 if you do it, 1 by 1.6 if you do it, so 0.625, 0.625 will get it, 0.625. So you can see, so 0.625 into 10 power 19. So in 1 coulomb, then you'll get 6.25 into 10 power 18 electrons are present. So in 1 coulomb, 6.25 into 10 power 18 electrons are present. I hope it is clear. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area. Okay, so 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Okay. So Q equal to plus or minus Ne. Q equal to plus or minus Ne. Sir, how can you say Q equal to plus or minus Ne? So actually here, so number of charges are moving in the conductor. So only one electron flows, we can't say current is flowing. Only 2 electrons flows, we can't say current is flowing. Only 3 electrons flows, we can't say current is flowing. So number of charges are moving in the conductor. Number of charges are moving in the conductor. So then that time only we can say current is flowing. That time only we can say current is flowing in the conductor. Current is flowing in the conductor. Understood? Yes. So that's why I am taking I equal to Q by T. I equal to Q by T. Right? Yes. So now Q equal to Ne. So Q equal to Ne. Q is nothing but, what is Q? Quantization. Q is nothing but quantization of charge. That is nothing but plus or minus Ne. N is the number of electrons. N is the number of electrons. Okay. N is number of electrons. We can say N is number of electrons. Okay, so number of electrons, that's okay, fine. So we know that one. On 1 electron, how much charge is present? On 1 electron, 1.6 into 10 power minus 19 coulomb. On 1 electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 6.25 into 10 power 18 electrons are present. On 1 electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 6.25 into 10 power 18 electrons are present. Okay, so that is nothing but, so on 1 electron, how much charge is present? In 1 coulomb, how many electrons are present? So that's enough. Coming to the next one, electrical elements. So now we will discuss about electrical elements. Let's do electrical elements. Electrical elements, those are positive cell. First one is cell. Positive terminal, negative terminal cell. Second one is battery. Positive terminal, negative terminal battery. And next one, third one, switch. This is switch, sorry, open switch. First open switch, then we can say closed switch. This is a open switch. Open switch. Next one, closed switch. Closed switch. Closed switch. And fifth one is resistor. Resistor. Next one, rheostat. 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 And next one, seventh one, ammeter. So positive term and negative term, ammeter. Next one, voltmeter. Voltmeter. So ninth one, wire joining. Wire joining. So 10th one, wire crossing. 11th one, bulb. So these are the electrical elements. These are the electrical elements. Okay. So now we can see first one is cell battery. Cell battery. Cell, battery, open switch, close switch, resistor. So here resistor. Resistor is a device. Resistor is a device which is used to oppose the electric current in the circuit. A resistor is a device which is used to oppose the electric current in the circuit. Okay. Resistance. Resistance is the phenomenon of opposing the electric current. So here, so point number one, resistor, and coming to resistance, and the next one is O, and the fourth one is symbol. So these are 4 points. So resistor is a device. Resistor is a device which is used to oppose the electric current. Resistor is a device which is used to oppose the electric current. Resistance is a phenomenon of opposing the electric current. Resistor is a device which is used to oppose the electric current. Resistance is the phenomenon of opposing the electric current in the circuit. SI unit of resistance is ohm, and symbol for resistance we know that. Coming to rheostat. Rheostat is a device which is used to regulate the current. Okay, regulate the current without changing the voltage source. So this is the rheostat. A rheostat is a device which is used to regulate the current. Regulate the current without changing the voltage source. Without changing the voltage source. So that is about rheostat. Rheostat. Understood? So ammeter, voltmeter, wire joining, wire crossing, and bulb. So coming to ammeter. Ammeter is a device. Ammeter is a device which is used to measure the electric current in the circuit. Ammeter is a device which is used to measure the electric current in the circuit. So voltmeter is a device which is used to measure the potential difference. Ammeter will be connected in series combination. Voltmeter will be connected in parallel combination. Understood? Once again, ammeter is a device which is used to measure the electric current in the circuit. Voltmeter is a device which is used to measure the potential difference. Ammeter will be connected in series combination. Voltmeter will be connected in parallel combination. Ammeter will be connected in series combination. Voltmeter will be connected in parallel combination. Understood? I hope it is very clear. I hope it is very clear. So these are the points. These are the points. Next one, wire joining, wire crossing, bulb. Wire joining, wire crossing, bulb. Now we will discuss about an electric circuit. An electric circuit. So what is an electric circuit? A continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. Okay, so it must be a closed path. So an electric circuit. Now you can see here electric circuit. We'll see electric circuit, electric circuit, electric circuit. A closed and continuous path of. So this is the bulb symbol, ammeter, so battery, switch. So current is passing. Say a closed and continuous path of an electric current is known as an electric circuit. A closed and continuous path of an electric current is known as an electric circuit. Understood? Here, so 2 points we have to discuss. One is conventional current, another one is electric current. First one is conventional current. Conventional current. Conventional current. So conventional current, and second one is electric current. Electric current. So conventional current is nothing but the flow of positive charges. Positive charges are moving from positive terminal to negative terminal. Positive charges are moving from positive terminal to negative terminal, whereas electrons are moving from negative terminal to positive terminal. Understood? So positive charges are moving from high potential to low potential. So positive charges are moving. So whereas electrons are moving from low potential to high potential. Electrons are moving from low potential to high potential. So why you are saying the conventional current and why you are considering the electric current? Conventional current is nothing but so before finding electron, protons, all those things, okay, electron, proton, neutron. So before finding this thing, so already scientists were following that, okay, that is the flow of positive charges is known as current. So after knowing this electron, proton, so we got it. The flow of electrons gives the electric current. Okay. So instead of changing all those things, better we will keep it same. Then we will mention as a conventional current. So that is the reason. So we are using conventional current and electric current. Conventional current is nothing but the flow of positive charges is known as conventional current. Electric current is nothing but the flow of electrons. The flow of electrons. Understood? I hope it is very clear. And one more thing, positive charges will move from high potential to low potential. Positive charges will move from high potential to low potential. Whereas electrons will move from low potential to high potential. Positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. Low potential to high potential. I hope it is clear. So there is one question on it. That is, will electrons flows from high potential to low potential or low potential to high potential? So remember one point, always electrons will move from low potential to high potential. Always electrons moves from low potential to high potential. I hope it is very clear, right? Conventional current and electric current. Conventional current and electric current. So this is about an electric circuit. So electric circuit definition: a closed and continuous path of an electric current. Okay, a closed and continuous path of an electric current is known as an electric circuit. Conventional current: flow of positive charges. Okay, so movement of the positive charges. Electric current: flow of electrons. Flow of electrons. I hope it is very clear. So this is about conventional current and electric current. So now we will discuss about so now we will discuss about potential difference and electrical potential. Potential difference and electrical potential. So I will tell one example. So I'm taking one beaker, so another beaker. So both beakers are filled until the top. So water is filled until the top. Okay, so fill the water until the top of the two beakers. And there is a path to one beaker to another beaker. So we connected that path. Will water flow from one beaker to another beaker? No. So it's not possible. Same thing. So one beaker is filled until the top, another beaker is filled until half of it is. So there is a path. Okay, there is a water flow between two beakers. Okay, connected. So now will flow. Water is filled at top to water is filled at half of it. So water will go right from beaker A to beaker B. Yes or no? So I'll give with the help of diagram. So I'll explain with the help of diagram. So these are two beakers. I'm taking two beakers. These are two beakers. Okay. So here you can see. So these two beakers are placed at the same height and filled until the top. Until the top. Here also, so I filled the water until the top. Okay. So I connected one way to one beaker to another beaker like this. This way and this way. So will water flow from beaker A to beaker B? Will it flows? No. It won't flow. So one more case. So this is beaker A. So it is placed certain height and another beaker is placed certain low height compared to this one. Okay, so like this. So it is filled at the top and here it is filled certain distance like this. So I connected this beaker. Now water flows from beaker A to beaker B. Beaker A to beaker B, it flows. Yes or no? So let me know. So beaker A to beaker B, it flows. Yes or no? So the water flows from beaker A to beaker B. Beaker A to beaker B, water flows. This is a beaker A and beaker B. So there is a difference. There is a pressure difference. Yes or no? So in the second case, so case 1, and case 2. In case 2, there is a pressure difference. Okay, so water flows from high pressure region to low pressure region. Understood or not? So here there is no change. Water will not flow from beaker A to beaker B. But in this case, water flows. Yes or no? Water flows. Right. Okay, I got it. So in the conductor also, electrons will flow. Will it flow its own? No. So there must be a difference. Pressure difference. Electrical pressure difference. Yes or no? Because of that reason only, electrons will move from one region to another region. Or charge will flow from one region to another region. So which one is creating that pressure difference? Electrical pressure difference. That is battery. If you connect the battery, then only, so current is start moving in the conductor. So current is flowing in the conductor. So which one is creating that pressure difference, electrical pressure difference? Battery. Yes or no? So here we are discussing about 2 points. Those are potential difference and electrical potential. Potential difference and electrical potential. Potential difference and electrical potential. Okay. So let's start now. Potential difference and electrical potential. Potential difference and electrical potential. So let's start. Let's discuss about it. Potential difference. So potential difference is nothing but, so there is a charge. So this is a point A and point B. So I am taking the charge Q, positive charge. We are doing some work. To bring unit positive charge from one point to another point. So we are doing some work to bring unit positive charge from one point to another point within the conductor. So we are doing some work to bring unit positive charge from one point to another point within the conductor. So that is called potential difference. So V equal to W by Q. So SI unit of potential difference is volt. SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. Okay. So SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. So what is the potential difference? Potential difference is nothing but so 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. Is called potential difference. Okay. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point, right? Now electrical potential. So what is the difference between potential difference and electrical potential? Electrical potential. Electrical potential. Okay, electrical potential. So electrical potential is nothing but, so this is a positive charge, it is at infinity. So this is the required place. We are doing some work to bring unit positive charge from infinity to the required field. Okay, from infinity to the required field. So we are doing some work to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. Normally if you see potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Coming to the electrical potential, work done to bring unit positive charge from infinity to the required field. Is called electrical potential. I hope it is very clear. Understood? So these are the points. So now we will discuss about Ohm's law. Okay. So next one we will discuss about Ohm's law. Let's start. Ohm's law. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. V is directly proportional to I, V equal to IR. Understood? Yes. Now you can see. So materials required. What are the materials required? Materials required. Materials required. First one is four cells of 1.5 volts of each, and the second one is nichrome wire is 0.5 meter length, and coming to third one, ammeter, and fourth one voltmeter, and fifth one switch, and sixth one connecting wires. Okay, connecting wires. So these are the materials required. Understood? Now procedure. Okay, so procedure is, first you have to connect one cell and note down the reading of ammeter and voltmeter. So next two cells, and third time repeat the process for 3 and 4. Okay, so you have to write, first you have to connect one cell and you note down the reading of ammeter and voltmeter, and connect two cells and note down the reading of ammeter and voltmeter, and repeat the process for 3 and 4. So I'll draw the circuit diagram. This circuit diagram you can check once here. Circuit diagram. Okay, so 4 cells, 1, 2, 3, 4. Okay, ammeter, and so resistor I am connecting. This is a resistor. Okay, resistor is nothing but so that is connected to voltmeter, like here. So positive terminal, negative terminal, current is flowing. Circuit diagram. First you have to connect one cell and note down the reading of ammeter and voltmeter, and connect two cells and note down the reading of ammeter and voltmeter, and repeat the process for 3 and 4. So you have to repeat the process for 3 and 4, and you mention in the tabular form given below. So I will draw the tabular form. So this is the tabular form. So you have to draw the tabular form like this. Understood? So serial number of cells, ammeter reading, voltmeter reading, we have 1. So serial number of cells, so ammeter reading, voltmeter reading, V by R, I equal to I. So V equal to IR, I equal to, so I equal to V by R, I equal to V by R. So here 1, 2, 3, 4, 1, 2, 3, 4. So ammeter reading is the current, voltmeter reading is the potential difference. Understood? So I hope it is very clear. If you if you draw the VI graph for ohmic conductor, VI graph for ohmic conductor, the graph is linear. The graph is linear. Understood? The graph is linear. Okay. So if the graph is straight line means those are ohmic conductors. What do you mean by ohmic conductors? The conductors which obey Ohm's law. The conductors which obey Ohm's law, those are called ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductors. The conductors which does not obey Ohm's law, those are called non-ohmic conductors. Conductors which obey Ohm's law, those are called ohmic conductors. Conductors which does not obey Ohm's law, those are called non-ohmic conductors. Understood? So here you can see. So V on y-axis, I on x-axis, the graph is curve. The graph is curve. I hope it is very clear. Understood? So that's enough. That is about Ohm's law. That is about Ohm's law. So next one, resistance and resistivity. Resistance and resistivity. So what is resistance? The phenomena of opposing the electric current. The phenomena of opposing the electric current is called resistance. Okay. So resistivity, you'll see everything. Resistance and resistivity. Resistance and resistivity. Resistance and resistivity. Let's start. Resistance and resistivity. Resistivity. So R is directly proportional to resistance. Resistance and here resistivity. Resistivity. Okay. So point number 1, R is directly proportional to length of the conductor, R is inversely proportional to area of the cross section. R is directly proportional to length of the conductor, R is inversely proportional to area of the cross section. Okay, so now you can see R is directly proportional to L by A, R is directly proportional to L by A. R is directly proportional to L by A. R equal to rho into L by A. Rho equal to L by A. So, resistance depends on temperature. Resistance depends on nature of the material. Nature of the material. Nature of the material. Understood here resistivity rho equal to RA by L. Resistivity rho equal to RA by L. So rho equal to ohm meter square by meter. Meter get cancelled. Resistivity equal to ohm meter. SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. Understood? Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. Rho equal to RA by L. So SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. Very, very important. So 2 marks question is very important for the exam. So try to practice it. Try to work out on it. Okay. So and even based on this one, problems also will come. So we'll work out on problems. Try to practice the problems also. Understood? So now resistivity depends on temperature and resistivity also depends on nature of the material. Nature of the material. Understood? So nature of the material. I hope it is very clear. So now, so we'll discuss about resistors are connected in series combination. Next, resistors are connected in parallel combination. Resistors are connected in series combination, then resistors are connected in parallel combination. Okay, let's start. Resistors are connected in series combination. Resistors are connected. Resistors are connected in series combination. In series combination. Series combination. Understood? So resistors are connected in series combination. So 3 resistors I am taking. So resistor, 1, 2, 3. So connected to ammeter. So we'll draw little below because every time I'm drawing, so same problem getting. So we'll change it. That is, I'm drawing here 1, 2, 3. So across this is R1, R2, R3, across R1 V1, across R2 V2, across R3 V3. Okay, that is I'm connected to the ammeter. So here battery, switch, positive terminal, negative terminal, current is flowing. So here current is flowing. So entire the circuit, throughout the circuit current is same. Throughout the circuit current is same. Okay. So throughout the circuit current is same. That's why I'm taking. So IS equal to I1 equal to I2 equal to I3 equal to I. Okay. Throughout the circuit current is same. But potential difference is different. Potential difference is different. Understood? Potential difference is different. So V equal to IR. From Ohm's law, V equal to IR. So from Ohm's law, V equal to IR. Understood? Now potential difference is different. So Vs equal to V1 plus V2 plus V3. Vs equal to V1 plus V2 plus V3. Okay. So now IRs equal to IR1 plus IR2 plus IR3. So I am taking I common. I you are taking common. So you can take I common R1 plus R2 plus R3. So I am cancelling I. Then RS equal to R1 plus R2 plus R3. R1 plus R2 plus R3. So resistors are connected in series combination. RS equal to R1 plus R2 plus R3. If n number of resistors are connected in series combination, RS equal to NR. RS equal to NR. So if resistors are connected in series combination, just you have to add all those resistance. So if n number of resistors are connected in series combination, RS equal to NR. RS equal to NR. Understood? So this is about resistors are connected in series combination. Now we will discuss about resistors are connected in parallel combination. Right? Okay. So parallel combination 1, next one 2, next one 3. So I'm connecting here. So ammeter. So that I'm reaching to the circuit. So current is passing. Positive terminal, negative terminal, current is passing like this. R1, R2 and R3. Across R1, R2, R3, and I'm connecting V. This is V. I'm connecting like this. So current is dividing I1, I2, I3. Positive terminal, negative terminal, current is flowing. So here also current is flowing. Now V equal to IR. From Ohm's law, so from Ohm's law, we can take, okay, I'll teach, definitely I'll teach physics, 12th grade physics. So V equal to IR, from Ohm's law, we can take I equal to V by R, I equal to V by R. So here BP equal to, so potential difference is same. Potential difference is same. So that is VP equal to V1 equal to V2 equal to V3 equal to V. Understood? Then IP equal to I1 plus I2 plus I3. That is nothing but V by RP equal to V by R1 plus V by R2 plus V by R3. So now I am taking V common. 1 by Rp equal to V, I am taking common 1 by R1 plus 1 by R2 plus 1 by R3. VV get cancelled. So 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is about resistors are connected in parallel combination. Resistors are connected in parallel combination. If n number of resistors are connected in parallel combination, so 1 by Rp equal to n by R, that is Rp equal to R by n. If n number of resistors are connected in parallel combination, 1 by Rp equal to n by R, Rp equal to R by n. I hope it is very clear, right? So that's enough. Just check once. Actually, this is the parallel combination. Resistors are connected in parallel. Okay, so this is a parallel. Resistors are connected in parallel combination. So if you like the content, if you like the channel, please do like, share and subscribe to Student in the Brand. Share to your friends, ask your friends to join to the class. So just to go and check the videos which are there in the YouTube channel. Okay, so I'll get to know. Now I'll teach heating effect of electric current. The source of energy continuously gets dissipated entirely in the form of heat. The source of energy continuously gets dissipated entirely in the form of heat. It is called heating effect of electric current. Okay. Or also, actually, it is also called Joule's law of heating. So V equal to W by Q. So we know W equal to V into Q. So rate of doing work is called power. VQ by T. So we know Q by T is I. And so P equal to VI. So energy is given to the conductor equal to P into T, and whatever the energy is given, that will become in the form of heat. So V equal to IR, V equal to IR. So IR into I into T, then we'll get H equal to I square RT. So heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. So this is also known as Joule's law of heating. Joule's law of heating. Understood? I hope it is clear. So we'll discuss about problems. Also we'll discuss few problems. Let's start. Okay. So next we'll discuss about problems. Let's start. Few problems. Magnetic effects of electric current. One more class I'll take. So that time I'll discuss. Solve this question. So I'm writing the question. Try to solve this question. A current of 500 milliampere flows in a series circuit containing an electric lamp and a conductor and a conductor of 10 ohm when connected to 6 volts battery, 6 volts battery, find the resistance of the electric lamp. So try to do this question. So students, on request to all, so please try to support the channel because I'm doing a lot of hard work. So I hope you can see. So try to support the channel, try to encourage the channel, share this channel to everyone. So inform to everyone. So I'm requesting to everyone. Okay. So please share this channel to everyone and inform to great students, so they can join and attend the class. So I hope it is very clear. So let my subject reach to everyone and my efforts reach to everyone. So I need your support, I need your encouragement. Without your support, I can't reach to the maximum number of students. So do support, inform to your friends, inform to your friends. So directly you are helping them also. So they will also get to know the concepts. So good content will be there, quality content will be there definitely from the channel. Content wise, so you no need to worry about it. Check once whatever I'm explaining, those concepts are there in the textbook or not, check once. So I'm following the CBSE textbook. Okay, so CBSE textbook, based on that one, based on the concepts only. So according to the flow only, according to the sequence only, I am following. So please inform to everyone, ask them to join to the class. So this is the help I need from you all. Okay, so if you like the content, if you like the channel, please do like, share, and subscribe to Student the Brand, and inform to everyone. Right? Thank you, and do the problem. Okay, so welcome back to the class. Here you can see, yes, correct only. The final answer is 2 ohm is correct. Very good. So you can see here, you can observe. First, you have to understand what exactly they given in the question. Okay, so check once here. So a current of 500 milliampere flows in a series circuit containing an electrical lamp, okay, and a conductor. So this is the conductor. When connected to battery, potential difference is given. Find the resistance of the electrical lamp. So we have to find out resistance of the electrical lamp. Okay, so that is a question. That is a question. Understood? So for that, what you have to do it? We know that Ohm's law, V equal to IR. V equal to IR, right? So now we can check given data, given that, given data. So what is that? Current is given 500 milliampere, 500 milliampere, and electrical lamp RL we have to find out. RC is given how much? So that is 10 ohm. RC equal to 10 ohm. Understood or not? Now, so we have potential difference also given 6 volts. Now we have to take it. Now you can see here. So 1 milliampere equal to 10 power minus 3 ampere. 1 milliampere equal to 10 power minus 3 ampere. Yes or no? 1 milliampere equal to 10 power minus 3 ampere. Now you can substitute here. So we know from Ohm's law V equal to IR and R equal to RC plus RL. So what is that? So resistance of the conductor, resistance of the lamp. We know the resistance of the conductor value 10. So 6 potential difference. Current is here you have to take I equal to 500 into 10 power minus 3 ampere because milliampere is given. So that is here you can see I equal to 500 into 10 power minus 3 because they given 500 milliampere. 500 milliampere. So substitute here 500 into 10 power minus 3 into RC plus RL. RC plus RL. Okay. So now 6 equal to 500 into 10 power minus 3 and here RC equal to how much? 10 plus RL we have to find out. You can take this value. So you can take down this value completely down like this. Then 6 by 500 into 10 power minus 3 okay equal to 10 plus RC RL. So we have to find out the resistance of the lamp we have to find out, no? RL we have to take it. Now so 600 into so 1000 by 6 into 1000 by so these two is get cancelled. Then 10 plus RL and 60. Okay, 60 by 5. 60 by 5 how much you'll get? So 10 plus RL that is 12. Means so RL equal to 12 minus 10. Then you'll get RL equal to 2 ohm. Answer. RL equal to 2 ohm. That is the correct answer. Understood? I hope it is very clear. Check once. Once again, so 500 milliampere flows in the circuit, electrical lamp, electrical conductor, potential difference, V equal to IR, I given, RL, RC, V, substitute the values and find out. Then you'll get the answer. So next question, we'll go to the next one. Shall we? So one more question. So we'll see. This question will you try or not? Try this question. That is a 6 ohm resistance wire. A 6 ohm resistance wire is doubled on itself calculate the new resistance of the wire. New resistance of the wire. Can you do this one? So how much you'll get the answer? So just subscribe. So shall I give time? 4 minutes time. 4 minutes time. It's 5:40 now. So 5:44. We'll see. Okay, so now you can see here. So this type of questions can be expected. So expected questions. So try to think about it and try to solve this type of questions. Okay. So here you can see I'm taking, so they mentioned this original resistance. So R equal to 6 ohm when R equal to rho into L by A. So here same material, so rho dash equal to rho. New one is not changing, so R dash we have to find out. L1 is how much, A1 is how much, we will check. Okay, so resistance wire is doubled on itself. Calculate the new resistance of the wire. So I'm taking this resistance. Initial is, so this is, what is this one? L, initially length. So half of it is, so it is doubled on itself. Means folded like this. Initially area of the cross section is A, length is L. So it is folded on itself. Okay. So it is folded on itself. So folded on itself. That's why I am taking this 2A and length is L by 2. So length is L by 2. Initial area, final area is A by 2. So this is the final. So I want to find out R dash. Okay, anyway, same material. So material is not changed. So that's why rho is not changing, right? So now we can take R dash equal to rho into L dash by A dash, new one. So R dash equal to rho is nothing but rho only, and L dash is equal to L by 2, A dash equal to 2A. So now, so rho into L by 2 into 2A, that is nothing but rho into, so separate you can write. Understood? Yes. So now you can see here. Now you can see. So 1 by 4 into rho into L by A. This 1 by 4 into rho into L by A is what? Rho. So what is that value? 6. So R dash equal to 6 by 4. 6 by 4 is nothing but 3 by 2. 3 by 2 is nothing but 1.5 ohm. Understood? So if you know this answer, if you got this answer, if you understood this answer, so you can subscribe, no? Subscribe and you can share to your friends. Right, yes or no? Share to your friends as much as possible. Do support. So inform to everyone. Okay. So inform to everyone. Share this link to everyone. Ask your friends to join to the class. Yes. Let's start next one. Next one. Next question. So when it is extended, that time length will double, so area becomes off. So one more question. So there are many questions are there, many questions. So among those questions, I'm giving few questions which are very important. Try to solve it. Okay. So a total a total of 6 into 10 power 46 electrons flow through a current carrying a current carrying a current carrying current carrying conductor when connected through when connected through an external power an external power supply for 20 seconds. Find the value of current in the conductor. Okay, so try to find out this question. So very simple. Try to read the question twice, then you'll get it. Understood? Share, subscribe. So time now 5:51. 5:51. So I'll give 4 minutes time. 4 minutes time. So 5:51. Now 5:55. I'll explain this question. Try to solve it. Okay, so check here. First of all, you have to write what is given data. N is given and time is given. Okay, so you can check given data, that is n equal to 6 into 10 power 46 and t equal to 20 seconds. T equal to 20 seconds. Understood? So now t equal to 20 seconds given. Understood? So on one electron, 1.6 into 10 power minus 19 coulomb. On one electron, 6 point, okay, yeah. So I equal to, from Hyderabad, okay. So now I equal to Q by T. Now Q equal to NE, Q equal to NE, Q equal to NE. So substitute that I equal to, so I equal to NA by T, I equal to NA by T. So I worked in Marathalli area, Bangalore, HSR layout, Marathalli. Okay. Electronic City, Kagadaspura. So I worked there. Okay, done. Come to the point. So here n equal to how much? 6 into 10 power 46 and 1.6 into 10 power minus 19. Then t equal to 20 seconds. Try to solve it. Try to solve it. Oh, Alhananka. How are you? What is your name? Great. Okay, chalo. So next one. The answer is answer is I equal to 4.8 into 10 power 10 power. So 10 power 26 ampere. This is the answer. Like this, like that also you can take it. 1 0 you can remove and multiply with that, you will get it. Correct. Okay. So thank you so much for joining and attending, listening. So this is our Sevasa. Thank you so much. So do like, share, and subscribe to Student the Brand. So thank you so much. We'll see in the next class. So if you like the content, if you like the channel, please do like, share, and subscribe to Student the Brand. Thank you.